Hey everybody, this is Larry. This is me going over Q4 of the weekly contest 227 closest subsequent sum. So this one I actually knew how to do immediately, and some of that is just because it's trivia. And there are a couple of ways to do it, or mostly two ways, and I took the slower way, and I got, just to kind of give you a little bit of a context, I got I got TLE in two different languages, even though I was sure it was roughly right. And then at the very end, so basically I did it in Python, it timed out, in C++ it timed out, and then in Java it got accepted. I think the first thing to notice is that this is just really knapsack, but n is equal to 40, and the constraints are so that you cannot do the pseudo polynomial dynamic programming. But given that n is equal to 40, well, what you should do is hit the like button, hit the subscribe button, join me in Discord, and ask questions about this and other problems. But yeah, but given that n is equal to 40, you can do something called meet in the middle. And this is a little bit tricky, to be honest. Because so this is a little bit tricky, because I feel like, well, one is that, if you don't have to worry about this for an interview. I don't think it's going to come up in an interview because it's just so very specific. But the idea behind this problem is just, okay, n is equal to 40. We split the problem into halves, and so that you have 2 to the 20 on the left side, 2 to the 20 on the right side, and that's just power set, right? And then merge them in a way that allows you to do it in good time. So that's basically the idea. Again, this is an explained algorithm. So knapsack, it's called meet in the middle, I think. So that's what I would Google on if you want to kind of add some supplement. I'll go over my solution, and in Python, even though my Java and C++ solution is mostly exactly the same, but I might make an optimization here because I couldn't think about this optimization during the contest because I was very annoyed that I was too tilted and annoyed during the contest. But afterwards I was like, oh yeah, this actually is not so bad. But the idea is that, again, we do a brute force on the left side, which is we just have to answer, and then we also do a brute force on the right side, which is the other half. And this the way that I wrote it is just the way that we do brute force power set. Definitely, if you're not familiar with this notation, I'll go over it another time because I want to focus on, but what this does is that it gets every combination of every sum. So basically 2 to the n, in this case 2 to the n over 2 possible sums, and then we do it again on the right side, and then we just do a binary search from the left and the right. And that's basically the idea. It's really easy to do, and like once you get the ideas down, it's kind of easy to do relatively. But again, I had some time limit issues. My only complaint is that I don't know why this is 40. They could have chose n is equal to 30, and it doesn't, remove any bad answers. I'm a little bit sad and salty about this one because I got this one real quick, and I would have been top 10 if this passed a seed. But I had to switch to C++ and then Java because it time limit exceeded in C++ as well, and then I did in Java, and it was okay. And the code is pretty much exactly the same, so it's a little bit sad. But there is one optimization that I didn't do, so let's kind of do it together as an so let's go over the complexity first, right? So what is the complexity of this, right? So this is going to be O of n, 2 to the n over 2, and in this case it is also going to be O of n over 2, but for each one we do a binary search on so this is times log of 2 to the n over 2, which, if you do your math, this is just equal to n, right? N over 2. So that's basically the complexity of this. And in terms of running time, because log of 2 to the k is equal to k, and that's basically, so this is the n running time of this. And given that n is equal to 40, this is about 20 million, but which apparently is a little bit too slow for this problem, but at least in Python and C++, but in Java it should be okay, or it was okay for me. And in terms of space, because we have this left set thing that we can binary search on, it's just gonna be O of 2 times times n over 2. That's basically the core part of this one. And yeah, and we're gonna do, the thing is that, you know, you trade different things, so I didn't know that whether this optimization would have made sense. But basically what we could have done is also just that, you know, right set is equal to basically the same thing, but we use the 2 pointers algorithm instead to merge the things. So then now instead of this, now we have, let's just say, right is equal to this set of right set, and then now we can just do, we can walk the DAG, and now we can do a merge by you know, going through the list, and you can do this in linear time afterwards, but to kind of get rid of the so we have this n times n over 2 factor, that's log of, you know, the binary search, but we can actually get rid of that, and that should be fast enough if you have 2 pointers and you kind of keep on moving it to kind of get the go. But yeah, but I didn't do that during the contest, and maybe I should have studied the literature a little bit more to kind of get that, but yeah, that's all I have for this problem. I'll leave the rest merge left as an exercise for readers at home. But yeah, let me know what you think. I'm, like I said, the concept is kind of interesting and cool. Let me actually reset this. I mean, I'll let you screenshot this for a second. Let me hold it here, and then let me go back to the submitted code so that you can kind of see the code that I actually submitted. And again, this with AC in Java, but not here. So I might have to do some research to kind of figure out how to get this to be fast enough in Python. I have talked to people, and it seems like there is like this code mostly works, or not, or this algorithm works even with the binary search, but they implement it another way and it works. So I don't know. Maybe it's just the way it is. Sometimes you get a little bit unlucky. I'm a little bit sad because I would have been top 10 or top 20, something like that, depending on how the time works. But you know, sometimes it's just a little bit sad. But yeah, that's what I have for this problem. But the core part is just divided in half, and then binary search the answer on the other half. Cool. Let me know what you think, and I will see. And you can watch me solve it live during the contest in 3 different languages. And I even tried to copy and paste the solution I solved or saw on the internet, but then I just couldn't figure out. That code was pretty bad, no offense. So I kind of rewrote it anyway. So yeah, and it worked in Java. Okay, that's all I have, and I will see you later. Bye-bye. Should be all load, I guess. Oh, people are really fast. I mean, this is just stupid. This is a standard problem. I expect a lot of people to get this way quickly, actually. Maybe not that. Let's see. I mean, this is a either you know it or you don't, I think. So this is silly. I haven't done this in a long time though. Oops, I mixed that up. That could have been dangerous. I mean, I think a lot of people actually already have this pre-coded, or these top people, I mean. Oops. Oh, oops. I missed that. If this is too slow, I would be sad. I guess I should have tried it though. I thought about trying it, but I was a little bit too confident. Okay, fine. I feel like that works in another language though, so that's a little bit sad. Yeah, let's try it in Java. Okay, let's do it in C++. So I think I have code here somewhere. This is silly though, that I have to do this. I don't know why it doesn't work in... That would be pretty... Let me take a look at this code again. No, it's time limited, right? So I know that this is... Okay. This is kind of sad though, because I 100% sure people have run this before and either copy paste or just have code somewhere. That's why it's so fast. How do I use bisect? Oh, lower bound, I think. Okay, so what do you want? Oh, jeez. That's a little bit annoying. Also, I forgot to sort it. Why? No, why is this wrong? I don't want to debug. This is so stupid. I should, like Python should have be good enough. Hmm. Oh my goodness. How do you get super then? I'll choose the whole array. Where am I going wrong? Where? So I should get -2. And here I should get 8. 8 and -2. Eight and -2. Why? Okay. Why? I can't believe this is like so dumb. Oh, did I mess this up? This is... I think I copy and paste wrong. This is goal minus that. Okay. I mean, I got it right the first time, but this is a little bit sad. So let's try a big case. Really? Am I missing something really dumb? Huh. I mean, this is just... It's either that or my implementation is really bad. Just gonna Google this. I mean, this is sad because I know how to do it immediately and I still cannot get it right. Understood. No, these bounds are intentionally like, this is the only way to do it, I think. Okay, let's... I don't know how... What? It just tells me the time limit exceeded, but doesn't really tell me anything else. Okay, fine. Let me just... Why? But why? Why is the time limit? Can I really optimize that much? This is silly. We don't know what to do on this one. Maybe I should have done it in C++. I saw this in oops. Okay. So I found a Java solution on the internet. Let's see if that works. This looks pretty bad actually, the code, but maybe Java is faster. I'm too lazy to do it again, though. I guess I don't know. I don't think that you can do it any other way. I could be wrong. If there was another solution, then because this is a canonical knapsack type thing. I don't know why they wrote their own lower bound, though. I'm pretty sure that's in whatever somewhere. Maybe I should have just rewritten it. I'm a mess right now. This is very silly in general. Because now I'm... Would be ridiculous. Okay, fine. Time to learn Java. Okay, fine. Let's take my seat. That'd be funny if, like, I end up having to implement this in 3 languages. I mean, this I don't think there's another case, but I also don't know why this is so slow. Maybe the set. I don't know. How many people have gotten this? I mean, this is a standard problem. I really should have gotten it. I don't know why this is so, like, the running time is so bad. Like, maybe there's minor improvements, but not that much, to be honest. What is the Java set thing? Hash set. I'm way off shape with Java, clearly. It'll be funny if this turns out to be still too slow, because maybe I just don't know how to solve this then. -5. If it's not present, it gives you a negative number? Why? I really don't know this interface clearly. Why does anyone do anything like that? This is slower though. This is slower than the C++ version, so I'm a little bit worried. No, maybe not. Maybe it's slightly faster. Let's run it again. Okay, maybe it is faster. Not sure about this one though. So returns. Yeah. This is still TLE. Oh my, I can't believe that they made me do it in 3 different. Hey, yeah, thanks for watching. Hit the like button, hit the subscribe button, join me in Discord. Let me know what you think about this problem and this solution, this explanation. And yeah, do have a good day and a good weekend. Stay good, stay healthy, to good mental health, and I will see you next problem. Bye bye.